please do click on the subscribe button and turn on the notification so you can get videos as we post them. This is going to be the first video we're going to be posting concerning data science, and today we're going to be discussing an overview of what data science is. What really is data science? You've been hearing of the word data science in the 21st century, and so we want to define the term data science. We want to tell you who a data scientist is and the core skills that are required of a data scientist. Alright, so to get started, I'm Okechukwu Joshua Otazi by name, just in case I didn't introduce myself in the first place. So the agenda for this course today will be, the first thing we're going to be discussing is the emergence of data science. And in discussing the emergence of data science here, we'll talk about some of the contributing factors, about 3 of them, that has resulted in the rise of data science in our world today. This is not the first time we're hearing about data science, but in the 21st century, the word data science is emerging. And we're going to look at some of the contributing factors that have resulted in the emergence of data science in the 21st century. The next thing we're going to be discussing is basically what is data science. In discussing what is data science, basically we need to understand who a data scientist is. In other words, our definition of a data science is going to be anchored upon the definition of a data scientist. Alright, so we need to understand who a data scientist is in order to have a better perspective of what data science really is. Alright, so the next thing we're going to be discussing is the data science skills that are required. Alright, so for you to be called a data scientist, there are some core skills that you must have, some basic requirements that you must have, and these are some of the skills we're going to be discussing in this video. Alright, so the last thing we're going to discuss is going to be an examples where data science has been applied and where it worked. Alright, so we have some examples where data science help to solve complex business problems, and so we are going to be looking at those examples where data science helps to solve complex business problems. We're going to be looking at examples such as the Walmart example and then the Target example. Alright, so please stay tuned and do make sure to subscribe and turn on the notification button so you can get lots of other videos as we post them. We're going to be posting lots of videos on Excel, lots of videos on Python, lots of videos on R. Alright, so please do make sure you turn on your notification button and click on the subscribe button to encourage us. Alright, so the first thing we're going to be talking about, let's just get into our agenda for today. The emergence of data science. Alright, the first factor that has resulted in the emergence of data science is the explosion in data generation. Explosion in data generation here, basically in the past, it was not easy to find data to use to run analysis. Data wasn't readily available. There was what was called the caged data or the proprietary data. It is quite different from what we have today called the open data. Alright, so back then, government don't allow data to be made readily available to members of the public, statisticians and analysts who wants to use the data to analyze. Alright, so it was very difficult to find big data as we have today. Alright, so data wasn't readily available for analysis. But today, we are seeing lots of tons of data being generated in megabytes and terabytes and petabytes. In 2009 specifically, Facebook announced that it had 1 petabyte of data, and Google also announced that it has about 15 exabytes of data. That's to tell you that we are generating lots of data today than we have ever generated in our world today. And so today we have data deluge. We are no longer suffering from scarcity of data. Alright, so a statistician or analyst can't complain that the reason why they can't carry out analysis was because of the non-availability of data. Alright, so from social media, the moment you send messages on Facebook, Pinterest, Twitter, Instagram, name them, you're already generating data. Alright, if you go over to the Internet of Things, once you pay your bill online, we're talking about our webcams and cameras, we're talking about different other sources, your Wi-Fi, your cars, all these things generates data. All right, and some other examples that we have are blockchains. We talk about the bitcoins, we talk about Ethereum's, etc. All of these generate tons of data. All right, so other sources of where we generate data are basically the websites. All right, so data generation today is no longer a problem for analysts. All right, we are generating lots of data than we can handle in our today's world. All right, another factor that has resulted in the emergence of data science is the affordability of technology. The affordability of technology here, in the past actually, aside from the fact that data wasn't readily available in big form, all right, there was also no technology to use and analyze or gain insights from this data. There was no technology like Python, like R, like Excel, lots of technology that we have today. The tools were manual, all right, so you had to use pen and paper to carry out regressions and make predictions. All right, so back then it wasn't easy to analyze data, and so everything was being slowed down, all right, because of the lack of technology. Aside from the fact that the technology wasn't even available, it was expensive, all right, so it wasn't affordable. All right, so it wasn't readily, you couldn't purchase, you couldn't go online as we can today and download softwares. You can't do that in the past. All right, so statisticians and analysts had problem analyzing data because of, one, the lack of data to analyze to analyze, right? And then the non-affordability of the technology in the past. But today, we're having data deluge. Lots of data are generated in large amounts that we can even handle with our sophisticated technology. And so some other technologies are already rising up and sprouting up. We talk about the R, we talk about Python, or Jupyter Notebook, with which we write Python codes. And we talk about Excel, we talk about Power BI, we talk about Tableau and the likes. So all of these technology help to facilitate data analysis and help to visualize the big data today. All right, so affordability of technology here, we're talking about Python. Python is used for data analysis, and today we can download Python, download the Jupyter Notebook, and start analyzing data. We have R, all right, so the R IDE environment, you can always write codes on the console and then help to analyze your data. We have the Tableau. I like to say Tableau is affordable because we have the Tableau Public, with which you can use to visualize your data. We have the Power BI, Power Business Intelligence by Microsoft actually. It's helped to visualize data. It works in hand with Tableau. All right, so it's like a 6 of one and half a dozen of the other. All right, so Power BI also help in analyzing data and visualizing data. And then we also talk about Excel. I know most data scientists will not agree with me when I say Excel. All right, but Excel can be used actually for data cleansing. And one reason why I like Excel so much is because Excel allows for compatibility. All right, so when you're working with an executives, all right, most of them don't know what Tableau is, most of them don't know what R is, most of them don't know what Power BI is and the likes. All right, what they really want you to do is to make it simple. All right, so that's what Excel helps you to do. All right, so with Excel, you know that the executive, the person whom you're preparing the dashboard for, has this same software, and so it can be easily adaptable. All right, so that's basically what Excel can help you do. It helps for compatibility. All right, so the next factor, which is very much important, which is the reason why I'm creating this course, is the shortage of skilled labor. You see, the data to analyze is rising in a geometric progression. The tools and software to use and analyze the data is also rising in a geometric progression. But then the skills, or the individuals with the necessary potentials and skills to analyze the data, is rising in an arithmetic progression. All right, so we don't have too many people who can analyze this data and generate insights and create advantages for businesses. And so that's why many businesses are willing to pay extra bucks just to have a good data scientist with the right skill. All right, so actually a report by the New York Times at some point in time said that the average salary of a data scientist is about $112,000, and that of a software developer is about $100,000. That's to tell you that there is scarcity of labor when it comes to data scientists. All right, so a data scientist is one who can readily analyze the data and tell story from the data. And so most businesses are looking for that unicorn data scientist that can give them an edge over their competitors. And that's why basically the talks about data science and data scientists is rising in our 21st century today, because the data is no longer a problem. The tools and technologies to use and analyze the data is no longer a problem. But then the skills to analyze this data is where the problem comes from. And that's why data science presents lots of opportunities for anyone who is willing to delve into the field. All right, so there are some predictions. I'm going to give you some wonderful statistics. The PwC actually said that by 2020, the global internet traffic should have risen to about 3.5 billion. All right, internet users. Then in 2020 also, IBM Mortaza Haida, in his book Getting Started with Data Science, said that the digital footprint of will be about 40 trillion gigabytes. And also, I've already told you about the New York Times report. The next other forecast actually by the McKinsey Global Institute talked about the lack of, or the shortage of individuals with data analytics skills in the United States will be about 100,000 or 140,000 individuals that lack the data analytic skills, and then 1.4 million managers who don't know how to readily analyze data. All right, so the next thing I'm going to be talking about right now, having talked about some of the contributing factors that have resulted in the emergence of data science. We've talked about the three of them, remember them. All right, so the next thing we're going to talk about is a definition of them. Our definition, I said it earlier, that our definition of what data science is going to be anchored upon who a data scientist is. And so in my list here, I first put the term who is a data scientist. All right, so we are going to define who a data scientist is, and then having defined who a data scientist is, the next thing we're going to talk about is what is data science. All right, so what is data science? And you need to understand what data science is in order for you to delve into the course. If you don't know what data science is, there's no need delving into the course. All right, so the next thing we're going to talk about is what is big data. What is big data? All right, so these three terms are very much important to a data scientist. Who is a data scientist? I love the definition so much by Mortaza Haida in his book in 2016, Getting Started with Data Science. I recommend that book if you're just getting started in data science. And I also want to recommend another textbook by Foster Provost and Tom Fawcett. He talks about data science in business. All right, so basically, Mortaza Haida talked about, he defines the data scientist as someone who provides solution to complex business problem by analyzing big or small data, using the appropriate tools and techniques, and then tell stories to communicate their findings to the relevant stakeholders. All right, so that's what basically who a data scientist is. A data scientist, from this definition, has two core skills. The first skill is called the science part of data science, or I will call it data analytics skills. All right, so a data scientist must be able to draw insights. Given big data, given a huge amount of data, you should be able to draw an insights from the data. You should be able to tell you should be able to tell a story. You should be able to see some patterns. You should be able to detect some patterns in the data by analyzing the data using the proper techniques. When I talk about using the proper techniques and tools, the proper techniques here can be maybe using the regression analysis. You know when to use the KNN model, you know when to use the support vector machines, and also using the right tools or technologies. Here I'm talking about using Python. Is it R you're going to use? Is it Tableau? Is it the Power BI? Is it even Excel? All right, so these are some of the science part of things that the data scientist must know. All right, so the next thing is, having analyzed the data and seen the pattern, you should be able to tell stories. Usually the stakeholders or the executives don't really want to know your jargons. All they really want to do is your ability to minimize the jargons and use visualizations to tell them a story from the data they have given you. All right, so you should be able to tell a story that makes sense from the data. All right, so those two core skills are what a data scientist must have. All right, so data science Venn diagram is what I want to discuss next. All right, the data science have a Venn diagram. Now, if you look at this Venn diagram very well and look at the slides that are shown to you, you will see that there is an intersection point for a computer scientist and then one who knows mathematics and statistics. Now, what this is telling you is that if you're good in computer science or IT, and then you're good in mathematics and statistics, trust me, you'll be good in machine learning. You want to go into the machine learning part of data science. If you're good in mathematics and statistics, and you're good in a business knowledge or domain, for example, if you studied marketing or you studied economics, and then that's what I call business knowledge. All right, maybe I studied a field. I studied economics, for example, in school, and that's my business knowledge. All right, now I'm good in mathematics and statistics. Now, if you're good in those two areas, trust me, you want to go into traditional research for economics. All right, so if you're good in computer science and you're good in economics, I'm using that as an example for the business knowledge now. If you're good in computer science and then you're good in economics, you want to start developing software for economics. All right, so but if you are good in computer science and you're good in statistics and mathematics, you want to go into machine learning. Now, if you are good in all three aspects, now you are a unicorn. That's what they call unicorn in data science. That's what most businesses are looking for. All right, so but you have to start from somewhere. All right, you probably have to start as with machine learning. You probably have to start with traditional research or software development. But all of these things, if you look at the yellow box, the yellow circle over there, it shows that all of these things are encapsulated in data science. And so data science is a whole lot of things. It's a whole lot of different things. All right. So the next thing we're going to be talking about, friends, are the skills required of a data scientist. I've already given you a glimpse of that in the previous slides. So the first skill that is required of a data scientist is data analytics skills. Right? A data scientist must be able to analyze data. Right? So there should be a proper mix for a data scientist of mind or of machine and mind. All right. So the next skill is being able to tell stories. Being able to tell stories. Here in data analytics skills, here we're talking about the ability to draw insights from complex data, from big data, whether primary data or secondary data, whether qualitative data or quantitative data. All right, using either qualitative analysis or quantitative analysis, you should be able to draw insights from this data. And having drawn the insights from this data, you should also be able to tell stories from the data. All right, there should be a proper mix of mind and machine, a proper mix of the science of things and then the arts. All right, so data science is a mix of both science and art. So you should be able to have these two skills, and the sum of those two skills is what results in data science. All right, so the next thing we're going to talk about is what is data science. Having understood who a data scientist is, the next thing we're going to talk about is what is data science. And in trying to understand what data science is, I love the definition so much by Foster Provost and Tom Fawcett in 2013. They try to differentiate between data science and data mining. And that's something very much important in our world today, because these two terms tend to be intertwined. They tend to be intermingled together, but they are actually two different things. All right, data science are the set of rules and principles or concepts that guides data mining. And so data mining is the extraction of knowledge from data. If you put the two dots together, you can define data science as a set of rules, principles, or concepts that guides the extraction of knowledge from data. what is big data? All right, in data science, you need to understand what big data really is, because you're going to be hearing this word most frequently from data scientists. They always love to talk about big data. So what is big data? I love the definition by PwC, and I'll recommend that definition for you. All right, PwC is a big data is a set of data that is too big or complex and that becomes too difficult to process using basic data management tools or techniques or traditional processing application. All right, so that's what big data really is, friends. All right, so big data is a set of data that is too big that we cannot use pen and paper to analyze. All right, so big data could be structured. All right, so when we talk about structured big data, what do we really mean? Structured data are data that are organized using rows and columns, organized in tables. All right, so a data that's usually organized in rows and columns, they're usually organized in tabular forms. All right, so these data are called big data. Unstructured data, what do we mean by unstructured data? Well, unstructured data are text. For example, the messages you sent on WhatsApp, your pictures, your videos are unstructured data. All right, so these data are very much hard to analyze. Most data we find on social media are unstructured data. The semi-structured data is another type of data. All right, in the semi-structured data, usually data that carry meta tags are called semi-structured data. All right, so when you see meta tags or descriptions on data, we call them semi-structured data. All right, so some other things I would like to discuss with you right now is the characteristics of big data. You always see this, data scientists always talk about this, friends. All right, so what are the characteristics that we have for big data? Doug Lanning in 2001 enumerated 3 V's of big data. He's actually associated with these V's of big data. He introduced 3 of the first 5 V's of big data, and the first V he introduced was volume. And so in talking about volume, we're talking about the size of data. The size of the data. Do they exist in megabytes? Do they exist in terabytes? So usually big data come in large volumes. All right, so that's the first thing you should know. The next other characteristics he talked about is velocity, the speed at which this data drives at us, the speed at which this data is being generated. All right, so every day on social media we generate tons of megabytes and gigabytes of data. All right, so usually big data is usually generated in high speed. Every seconds, every minute, big data is being generated. So the speed of the generation of this data is very much important in identifying big data. All right, so another characteristic is variety. All right, so the variety of big data, usually big data don't come in one form. All right, so big data can be structured, unstructured, or semi-structured. All right, so they come in different structures. We've already talked about it, the types of big data or the type of data. All right, so it can come in different forms. Usually they don't come in a single form. All right, so other V's were introduced. These were the 3 V's that were introduced by Doug Lanning, and then other data scientists added some other V's like veracity. Veracity talk about the abnormalities or big data hubris. All right, so these are some of the abnormalities that blur the truths that can be extrapolated from big data. All right, so usually we see some noise in big data that blurs the truth that we can get from the big data. All right, so veracity is another characteristic of big data. Value, usually every big data should add value, and data in itself is useless. Data in itself doesn't have any use. All right, data is just a means to an end. All right, so big data should be something that can add value to an organization. All right, so there are other V's that were introduced by other data scientists that I'm going to be discussing. All right, so other V's that were introduced are, the first is validity. Are the data valid? All right, so that's the first thing you want to ask yourself when you get big data. Are these data valid? All right, when we talk about validity, how far back in time? There are some times when we want to generate big data and we are running back into previous years. All right, so sometimes some previous data may be useless in present time concerning what we want to analyze. All right, it doesn't mean that the data should not be stored. Every data should be stored. All right, but there are some data that are not valid concerning the analysis we are undertaking. All right, so big data should try to encompass. They are always valid. All right, so we're talking about validity. We're talking about how far back in time or how useful is the data to analysis. So we're talking about the worthlessness or how useful the data is to analysis. All right, so the next thing we're going to be talking about is the volatility or variability, all right, of the data. All right, so in talking about the volatility of the data, usually if your data is in one form, for example, if I have a data spanning 1,000 rows and I have all the values in the data is 2, 2, 2, 2, 2. Now, if I take the mean of that value of that data, definitely the mean is going to be giving me 2, meaning that the data is useless. All right, because the mean is going to give me 2, the median is going to be 2, the maximum is going to be 2, the minimum is going to be 2, and all the 5-point summaries also. All right, so basically that data becomes useless. All right, so some other thing we want to talk about in big data is the visualization. Big data should have the ability to see and be seen. All right, we should be able to visualize big data. That's what makes it a big data. We should be able to see them. All right, there are other V's I'm not going to be talking about right now. You can go ahead and read some other V's of big data. All right, so the next thing I'm going to talk about are the types of analysis. Basically, we have about 5 types of analysis, sorry. The first analysis is the descriptive analysis. In the descriptive analysis actually tells you what has happened. All right, in the descriptive analysis, we have what is called a 5-point summary: the maximum, the minimum, the upper quartile, the middle quartile, and the lower quartile. All right, this 5-point summary can give you a brief view or a brief hint of how your data is structured. All right, so the mean also and the median also are part of the descriptive statistics that we use to describe what has happened. It can tell you how skewed your data is. Is it right skewed? Is it left skewed? All right, so descriptive analysis tells us what has happened given our data. All right, so the diagnostic analysis is tells us, it moves a step upward and tells us why it has happened. All right, so it doesn't just tell us what has happened, it tells us why what has happened has happened. All right, so the next analysis we're going to be talking about is predictive analysis. Lots of data scientists usually confuse the two terms, prediction and forecasting. All right, so but these two terms are actually very much word apart. They're very much different. All right, so when you're predicting, you don't have to predict with respect to the future. All right, so predicting can be with the past, with respect to the past. All right, but forecasting has to always be in relation to future times. All right, so if we're in 2020, for example, and I want to forecast, I must forecast for 2021. I can't say I'm forecasting for 2019, but I can predict for 2019. All right, so that's basically the difference between the two terms. So in predicting, predicting actually talks about determine the value of y given x. All right, so but in forecasting, determine the future value of y given a value of x. All right, so basically the next type of analysis we are going to be talking about is the prescriptive analysis. Prescriptive analysis basically it tries to prescribe or make recommendations on what we should do to achieve a particular value, what should be done for us to achieve a particular expectations. If, for example, the example I used previously, all right, so for example, I have a linear regression model, y equals to an intercept plus my slope and then x. Of course, I already know my intercept and I already know my slope. All right, if, for example, I want to prescribe, all right, maybe the manager tells me that by next year we want to have a growth rate of about $50,000. All right, I can determine to put my dependent variable to be $15,000, and then with that, if I calculate the mathematics, do the analysis, I'll be able to determine what my explanatory variable should be. All right, so if you fix your dependent variable and try to determine your explanatory variable, then you are prescribing, or you are trying to prescribe what should happen in order to achieve a particular goal. In Excel, we have what we call goal seek. Goal seek actually help us in prescribing. All right, so the next analysis, which is the last analysis, is the autonomous analysis, or what's called the adaptive analysis. Usually managers want to see your systems, not just your model, because the underlying scenarios may change, the underlying assumptions may change. All right, so how adaptive is your model or analysis to changing circumstances, to changing assumptions? All right, so that's what basically adaptive analysis talks about. All right, so data analytic framework. Usually, data analytic framework, I have an advice for data scientists. The first advice I have is always start with the end in mind. All right, when trying to analyze the data, when you're faced with a business problem, always start with the end in mind. And starting with the end in mind, the first thing you want to know in the business problem is the outcome. What is expected of you as a data scientist? What analysis, what do the manager want you to achieve as a data scientist? And so we want to know the outcome, what is expected of us. Then the next thing we want to find out in the business problem, in order to better give us a better view of what the problem really is, the next thing we want to look at is actions and then decisions. Who makes the actions? Who takes the decision? Who makes the decisions? All right, so the decisions are usually made by a group of executives, and then the actions are taken by the employees. And so the next thing we want to look at also is the insights. The decisions and actions usually link insights and outcome. All right, and so in the insights here, we talk about get your data, explore the data, generate an insight, and tell the managers what to do. All right. In the discovery session, then we'll now be able to streamline our problem. All right, so if we start with the end in mind, if you look at this particular diagram, you'll find out that it is turned upside down. All right, in what we learned in statistics, or what we usually know, is you always first define your problem, then generate the hypothesis, which is this last section over here, discovery session. If you look at this section number 4, discovery session, where we talk about problem definition, the subsections here are define hypotheses and the likes. All right, so that's what we always want to do here. This is always our number 1 when we start working on the problem. All right, but in order to get what this shows you is what you should do before beginning analysis, before beginning to get the data. right? Before beginning to do anything, analysis or whatever, you want to start with the outcome in mind. What is expected of you, who takes the decision and actions. You want to know all of this information, and then you want to know what tools and technique you're going to use to generate analysis, and then you want to that will help you give you a better definition of your problem. And now once you're done with this step, now the next thing you want to do is to turn this upside down and start with this number one. So discovery here talks about defining your problem, and then having gotten a better definition of your problem, you want to then define your hypothesis. Still in this discovery stage, define your hypothesis, and then after having gotten your hypothesis, then the next thing is to generate insights. You get the data you have to use for analysis, then you explore the data using the appropriate tools and then technique. All right, so then the next thing is present it to the executive, the board of executives. Let them make the decisions and let the employee carry out the actions, and then your outcome or the expectation is going to be achieved. Trust me, friends, this works pretty well. I learned this from PwC, a course I did with PwC, data-driven decision making, actually on Coursera. All right, so types of analysis. The types of analysis we have basically, I'm going to be talking about the types of analysis based on the types of variables. Basically, we have the qualitative analysis. The qualitative analysis actually deals with categorical variables. When we talk about categorical variables, it can be binary variables or dichotomous variables, and then the polycotomous variables. If we have two categories, we call them binary variables. If we have more than two categories, we call them polycotomous variables. All right, so these are basically, it can be 5-point Likert scale variables. It can be the yes or no answer. All right, so usually we carry out qualitative analysis such as using the techniques such as logit model, probit model, and the likes in order to gain insights from the analysis. And so the next type of analysis is also called the quantitative analysis. In quantitative analysis, we use continuous variables variables that span multiple years, right? So in this case, you want to do the classical linear regression model and some other models, right? The types of data we're going to be discussing here today are primary data. All right, so primary data are first-hand data that have never been used anywhere before. You're the first person that's getting the data. You're the first person running the analysis, and so we call them primary data. But then we also have what we call secondary data. Secondary data are data you get from maybe statistical bulletins, or maybe you get on social media, a data that you did not generate yourself. Somebody had generated it. You're just using it for your analysis. All right, so those are the type of data. And so to finalize this, we're going to be ending with the examples where data science has been applied and it worked. All right, friends. Basically, I'll be discussing two examples, the Walmart example and then the Target example. These are the two most popular examples we have, basically, in data science. If you want to get more on this, I will advise you to read the book Data Science for Business by Tom Fawcett and Foster Provost and Tom Fawcett, actually. I would like you to get the book and then read more about the Walmart example and then the Target example. All right, so Data Science for Business is a very wonderful book for data scientists. All right, so let's get started with the Hurricane Francis. During this time, actually, there have been previous hurricanes in the past, and so Dillman, the chief operating officer of a store called Walmart. I know you don't know about Walmart because Walmart is not as popular as Amazon, but then it's a retail, an international retail store that sells lots of products ranging from baby products to water to adult materials and the likes. All right, so several hurricanes had happened in the past, but this time around, Dillman wanted something out of the box. And so he rallied a set of data scientists and then provided them with data on the purchase or the consumption patterns of consumers in the past hurricanes. And so he wanted to know what consumers are likely to buy, what product is likely to sell the most during times of hurricanes. All right, so the data scientists collected the data and ran an analysis. Well, you would expect that during times of hurricane, customers should be able to, the selling product should be maybe bottled water, maybe DVDs and the likes. You would expect that common things like that should be what would be selling the most. But then Dillman didn't just want something that was just usual. He wanted something out of the box, something extraordinary, something that is mind-blowing. And so when the data scientists analyzed the data, they found that a product like strawberry Pop-Tart sold more than 3 times its normal sales, right, during times of hurricanes. And then the highest selling product was beer. And that was awesome, actually. You wouldn't expect that a product like beer would be the highest selling product during times of hurricane. It's out of the box. I mean, all right. So, but then this was some of the findings that the data scientists found, that during times of hurricanes, strawberry Pop-Tarts usually sell 3 times more than the usual sales. And then beer was the most sold product in the stores. Right? This helped them to better stock their shelf and then get more sales. Right, so Target example, it's another very wonderful example on data science. Usually this time around, Target is another firm or another retail store. Actually, this time they were in competition with their competitors, and they were trying to find out what set of products sell the most in their store. All right, so data scientists took the data, analyzed the data, and were able to find. They found that if you can get nursing mothers to buy baby products from their store, from the store, you've gotten them to buy every other thing from that store. All right, so they were able to find awesome. They were able to run awesome analysis, and they found that if we can get a nursing mother to buy baby products from our store, we can get them to buy every other thing from our store. Well, this was something very awesome, and then the competitors stole the strategy and then also applied it in their stores, and it worked for them. And so it wasn't a new thing anymore, because most people were trying to get nursing mothers. Every other store was trying to get nursing mothers to buy baby products from them, because they are certain that the nursing mother will buy every other thing from them. And so Target wanted to take it a step upward. And so they started asking the question, like, how can we know someone is expecting a child? How can we know someone will soon become a nursing mother, even before they become a nursing mother? And so they found out from the analysis that usually nursing mothers, or before someone becomes a nursing mother, their diets change. There are certain things, there are certain behaviors that change about them, and one of it is the change in diets. And with that, they were able to move a step ahead from their competitors, and were able to predict those who were to be nursing mothers even before they become nursing mothers. Right? So these are some of the applications of data science, and how data science can help us in our real world situations. You yourself, data science can help you do lots of different things. And so trust me, data science is emerging, and data science is helping businesses to gain advantages. It can help in innovations. It can help to ensure efficiency. Data science can help to unseat competitors. It can help to create new markets, and lots of different uses of data science. I want to say thank you so much, and God bless you. Actually, this course is a short course, and so we'll be stopping here for today. And so please do subscribe and then turn on the notification button so you get notified whenever we post some more videos.